of the AI Dev series. I'm really glad to be here today, and the topic of today, it's a really interesting topic. And I have to tell you that I've been practicing, but I haven't been able to say this correctly. So I actually wrote it down. So we're talking today about Retrieval Augmented Generation. But to do so, I won't be alone here today. We have two special guests here today with us. So let's welcome Sergio and Filipe. They work in our professional services. They, better than me, they can present themselves. They're here from OutSystems. So Sergio and Filipe, hello, welcome.
Hi, everyone. My name is Filipe Martins. I'm with OutSystems since 2018. I'm a technical solution delivery lead, and I've been interested in this topic related to AI about 1 year ago, when this became to be considered like mainstream, and I've been investigating this topic a lot, and I'm very glad to be here with you today. So I hope to teach or pass you some valuable information.
Hello, everyone. Hi, Bruno. Thanks for having us here today. I'm Sergio Dias. I'm the head of development Lifecycle team at Professional Services. My team usually works a lot with customers, directly with customers. They are called the experts on the platform. So, and I'm very proud of that because they are really, really good. And we also work with defining the best practices around using the platform in the areas of architecture, DevOps, and also app security. And that's the main thing. Regarding AI, it's a topic that I started investigating probably around beginning of the year, a bit earlier. And I think this topic today is very interesting and was one of the first things I started to try to understand how it worked.
Well, thank you for being here. It's for sure it will be great. So what you're going to talk about is it's related also with your experience, right?
Yeah, so we've worked in some use cases internally, and we've been able to implement these kind of techniques using the Retrieval Augmented Generation with some success, let's say. And I think it's important to know the fundamentals, and it's what we are going to focus here today, so that everyone understands it's not magic, but it's something that everyone can really achieve, and especially using OutSystems, it's going to be very easy.
Okay, so it's not vaporware. You're showing things that actually have already been...
Well, the demo is going to be with you, so, and I think we have a special guest, so we don't know if he's going.
Oh, really? Who's the special guest?
Well,
oh, Murphy. Yes, yeah. Usually when there's a demo, you don't even need the demo, right? So Murphy to show up. Really nice touch. So okay, so what
you are in the spot now.
So what do you have for us, Filipe?
So today we're going to talk about RAG, Retrieval Augmented Generation. I'm with you.
Yes.
This is well, this is not native to us, English language. So yeah, there are some words that are difficult to us. Okay, so everyone, thank you all for who's online and who's watching this probably in a recorded version. Today we're talking about Retrieval Augmented Generation. But before jumping into Retrieval Augmented Generation, I wanted to talk about generation itself. So let's understand generation before jumping into the Retrieval Augmented. So what is generation? Generation is basically based on LLMs. LLMs, as much of you know, are large language models. What are large language models? These are advanced artificial intelligence systems designed to understand, generate, and interact with human language at large scale. They are the core systems behind many systems we use to see today everywhere, like chatbots, natural processing language systems, virtual systems, etc. These modules are trained based on huge amounts of information, and the training process enables them to grasp grammar, context, and even the subtleties of different writing styles. Finally, they are able to perform a variety of language-related tasks, such as writing, answering questions, comparing text, summarizing, translating, and more and more. They are actually invaluable tools in both everyday applications and specialized fields.
Okay, so Filipe, let's say a lot of us sometimes just say everything is ChatGPT, but actually ChatGPT is not the word, right? LLMs is what these systems, the name of those systems,
Yeah,
right?
so ChatGPT is possible the most well-known LLM at the moment. So it's quite easy to think they're the same, but actually ChatGPT is an LLM.
Okay.
It happens to be the most well-known.
Okay, got it.
Okay, so how do these large language model work? And for this, I would ask you to follow me with a simple example, which I believe it will be useful. So imagine you have a dictionary with a list of all the words, where all the words will have a unique ID. In this example, we have amazing with ID 1, apple with ID 2, aquarium with ID 3, etc., until the last word. And here you see the 600,000. This is because usually the dictionaries in the English dictionary has about 600,000 words. Depending on the language, we can have more or less, but just for this exercise and for us to understand, let's consider 600,000 words. You have the dictionary. Then you have our text, our context. And our text in this example is a sentence. This sentence is composed in 4 words. And we can translate or decode this sentence, translating their words to the corresponding IDs. Just for example, if you do the math, it doesn't make right. OutSystems shouldn't be 80, but this is just an illustration exercise. Let's consider OutSystems with ID 80, mates with ID 73, etc., etc. So based on a dictionary with IDs, we can also have our text translated into IDs as well, and the mapping is quite simple. And picking this, let's actually dive into what an LLM does. So picking in our sentence, let's look only at the last word, the word it, and let's make this question to the LLM. And the question is something like this: hey, LLM, based on everything you know, everything you learn all around the internet, what should be the most probable word that comes after the word it? And the LLM will go to its database and look under ID 50, which corresponds to the word it, and returns, okay, for the ID 70, I have 3%. For the ID 30, I have 3% possibility. For the ID 2, I have 3%, and so on and so on. And if we translate these IDs to words, what the LLM is telling us is that the next most probable word would be feasible with 3% chance, important with 3% chance as well, necessary, possible, earlier as well, and many other options. We have melt with almost 0, so not very likely. And basically this is it.
So this is a probability game.
This is just a probability game.
Okay. So no black magic, just
no black magic,
just mathematics and probability. Is that what you're saying?
That's if you live here today and understand that this is simple math, I consider I have done at least a medium job.
I like you saying it's simple math, because now you lower the bars.
I will not disclose this, but if you dig deeper, you'll see that it's just very basic math operations. Okay. That's why I say it's simple math.
Interesting.
This mapping is just simple. You could do this in your own spreadsheet. You would need like 50,000 times 50,000 combinations. If you have a spreadsheet that can cope with this, you can do it. Okay, this is quite simple, Bruno.
Got it.
Trust me.
Got it.
Okay, now picking the last exercise after the word it, but let's add something before. What if we now ask the LLM, what is the most probable word that comes after the words makes it? What we're doing here is adding words or adding more context to our problem. And we automatically see, following the same rationale, that for these two IDs, the 73 and 50, we have the same words, but with different probabilities. We automatically are seeing that possible and easier are the most probable ones, with 35 and 25%. So the takeaway from this is that you are already seeing that the more context you add to your problem, the more accurate the outputs will be. So here is why is it important for you to add as much context as you can.
Okay, that links to our prompt engineering session that we had on the last session. That I remember Mena was here with us, and he was talking about the importance of having a good context when we were prompting the system. So I think that really connects with what you're saying.
Exactly. And now you understand at least the math that is.
Yeah, exactly.
Okay. Now let's add even more context. OutSystems makes it, and I won't do all the rational again, but with OutSystems makes it, we already can detect the best two candidates would be possible or easier with 50 or 65%, which already told us, okay, these are words that we can confidently say this could be the next words, and more important than that, this makes sense, because remember, he's doing this based on the knowledge he acquired from vast amounts of information. If you let me add an example, it hopefully will help you understand. Imagine I have a big text about myself, explaining the history of my life, and the last sentence would be, and finally I was able to go to Bruno, where I was able to go to.
Okay, well,
don't know, right?
Yeah. I was already doing the math, but it was not simple math.
I read my text and understood, for example, I was born in London, I studied in London, then I went abroad, worked, but from the text, you would understand my ultimate goal would go to return home. So I finally could come back to
London.
London, exactly. So
probability 99%.
The more context you have, the more educated.
I get it. Yeah. Makes total sense. Yeah.
Okay. One thing that I forgot to mention in the previous slides is that the number of possible combinations is always 50,000 times 50,000. This is different from the 600,000 in the beginning, because the LLM dictionary will use around 50,000 words, not the complete.
Okay, not the complete list of words. Okay.
Okay. Now, if what I explained is so methodic, is a process that looks to have the rules so well defined, how does creativity comes in? Because every one of us have heard LLMs can be creative. They can create things that do not exist. So where does creativity come from? And this is where it enters the concept of temperature.
Okay.
So what is the temperature of the module? The temperature of the module is basically, very simply, the amount of creativity we are allowing the module to have. If we consider the temperature as a thermometer you have to measure your temperature, it can be cold, it can be hot, it can be warmer. And with cold temperature, we're basically defining that we are not allowing the model to have any creativity at all. So this, what actually means in practice, is that the model will suggest always the most probable word in the sequence.
Okay, math again.
Math again.
Okay.
OutSystems makes it easier. It's the most probable word. And because it has no creativity, we also consider to have more accuracy.
Okay.
Okay. So here I have an example. I went to ChatGPT, asked, build me a sentence with OutSystems makes it. Be concise. This is me telling, don't be creative, or set the temperature very low. And he tells me OutSystems makes it easier, and the text actually makes sense. Now the worm. This is where we are allowing some creativity to come in. We're not allowing too much creativity. We're allowing some creativity. This allows us to at least guarantee that the module will have some creativity, but still output something that makes sense.
Okay.
Okay. And here in practice, what happens is that it will suggest randomly among the most probable choices. Okay, there's math here again.
Yes.
With random, and it's the most probable. So here it could be either possible or easier. And once again, I have
for every single next word, this would be applied, right? That's yes. The way. So everything is like a chain, and you're doing this probability check along the chain, right?
Exactly. So imagine for a big text, if you start to have creativity in the first word,
it will propagate probably for the rest. Okay, makes sense.
So the hot temperature, basically, it will suggest randomly among all the possible options. You can get possible options, not so possible options, which will also will return you things that it doesn't look to make sense.
Okay.
Just think about an artist that it's very creative, and you look at its paintings and you say, "This doesn't make sense." It's always
So next time I went to a
Yeah.
museum and I see something like that, I'll say, "Oh, this is a very hot temperature."
Yeah, exactly.
It make me look like an expert, right? Maybe not.
And here you have a clear example when it says OutSystems makes it more than just a journey. It's a portal to realms where ideas bloom into reality with a mere thought.
Exactly. And what have you been drinking, sir?
Okay.
Okay, great.
And this can be considered hallucination. But hallucination is basically when the model generates incorrect or made up information. This can happen due to hot temperature, but this can be corrected, like just change the temperature value. Or more commonly, it's tied to the problems in training the module, or even the methods used weren't the correct ones. The data that was used to train the module wasn't accurate or was out of date, etc. So I'm putting this slide for you to be aware that this problem can be severe because it leads to misinformation and ultimately can undermine the reliability of the model.
Of the models, okay. That's important to know, right? Because from the experience that I'm having, and sometimes people, and again, ChatGPT, the one more uses, they actually have a disclaimer on the bottom saying, well, the model can be wrong, right? But it's sometimes people just read it. It's like the internet. If it is in the internet, it's correct. So we need to be careful with the information that comes because, again, it's just probabilities and math, and the words that come doesn't mean it's true, right?
Correct, exactly, completely. So large language models issues, they're based on a closed set of data, and they're subject to hallucination. We already covered this.
Okay.
Right? And because the set of data is closed, the data may be outdated, which will cause outputs that are not, maybe they were correct in the past, they might not be correct now. Also, we do not have any context or source. The LLM will give us output, but it doesn't say where the output comes from, so it doesn't allow us to at least validate if the information is accurate or not. And finally, training the model is very computing intensive. And this means it's expensive. Euros, dollars, it's expensive.
Just taking all the information in the world and training, you're saying expenses. Yeah. That's what you're saying?
Just imagine the first part where you have the probability of the next word. We did for 1, 2, and 3 words. Imagine this with thousands.
Yeah. It's just a lot of computing power, energy, and time.
Exactly.
Okay.
So to sum up, large language models are great at guessing the next word. The base of knowledge is a closed but huge set of data, usually information available publicly throughout the internet, and it's scalable, adaptable, and allow personalization. Okay. Now, digging into Retrieval Augmented Generation, Sergio.
Yeah. So now that we know all about the black magic of LLMs, and we've explained it very well, let's try to understand how can we leverage these models to do something more interesting. That is typically the first thing that even customers ask us is, how can we leverage this to use our own data and trust that it's going to give us answers based on that. And that's where this RAG, or Retrieval Augmented Generation, I didn't use the sheet.
You didn't need it. I was envying you the way you said Retrieval Augmented
Generation is this technique that is used to combine the power of the LLM with the data that we have, so that we can bring more accuracy into the table, into the answers that we are giving, and also making sure that we are using information that is up to date, and with this build trust with our users, with people that are using our tools in this generation, to make sure that everything is fact-based, and in fact that we are providing information that can be trusted. Okay, it's also a cost-effective way of using our data, because as Filipe was mentioning, training LLMs with a lot of data, and also including our data, can be very costly, and might not be the best way of building these systems to use our data. Okay, so it also helps us with the hallucination problem that Filipe was talking about, because now we're bringing more context into what the LLM knows, and with this we are grounding it into a more accurate response based on that context. So and that's it. So we want to use this technique to improve on those things that Filipe mentioned before that are still a bit the caveats of using the LLMs.
Okay.
So let's understand how, with an example, how this can work. So let's, for instance, have this question. So imagine that you go to your favorite LLM and ask, when was Portugal founded? And the LLM will answer you based on the training data that he has, okay? And so it will answer me in this case. So Portugal was founded in 1128, okay?
That's a question for the audience.
Is it right or not? So do we have confidence on this answer or not? Okay. So this is a question that sometimes we have when we are using the LLMs: is, do I have confidence in this answer or not? Okay. So the issue is, as we were saying, so we in this answer are not seeing what's the source to fact check it. Okay. So we don't know if the training data came from a reliable source or not. It might be out of date. Probably not in this case.
In this case, yeah.
Something that happened a long time ago, but we know that, for instance, when ChatGPT arrived to the market, we know that it was only trained into a specific date, and answers after that.
A classic example was the Olympics of Japan. So results, and no, it was kind of one simple example, because it was trained with data before the Olympics in
so that's
Japan.
Keeping the data up to date is something that's not very well solved in LLMs yet, and there's also the possibility of might not be correct, might be hallucinating in this case. Okay, and so this is the simple query that we use, the simple prompts that we do. And so how would we do the same thing using RAG? So I would ask the question the same way, and then the first thing that my system would do would be to get additional context, okay, from a reliable source, from my data, okay? In this case, we would use our Portuguese Republic information from the website, where it's the official one. So
let's hope the state is not lying to us. But yes, so looks like a good.
Let's trust that, and then we would get the context from there, and then getting that context and adding it to the prompt and putting all of that to the LLM so it can generate an answer would be something that the system would execute, and then it would give us the answer 1143. And as you can see, it's different from the previous answer.
Right.
But this one is grounded to the context, the information that we provided, and it's the official one. So I think we need to trust it. So this is the poor man RAG example, where even with a small copy and paste, we could add into the chat interface some context, some additional context, and just use the LLM to generate an answer in the format that we want. Okay. So this was the simple example. And what are the differences that we have here using this technique? So the model would have the instructions. So along the context and the prompt, we also would have instructions directing the model to pay attention to that context that we are giving to it, and to focus on that. Okay, and so we are grounding the answer to that context. And then we also ensure that we are using the latest data, because we are retrieving it from the website. So it's the latest one, the latest information. I think this is not changing.
Hopefully not.
In some cases, if you will have news or something else, or the Olympics results or something else, you would need to always be feeding the most updated content, of course. So it's less likely to hallucinate, because we are telling it to refrain to that context and not to the information that is trained on. And even we are saying, so if you don't know, if the answer is not in this context, don't give an answer, and that's also a valid answer. Okay. Instead of trying to give something.
Right. Well, I think, again, that's aligned with the prompt engineering session we had. That is trying to guide the model to give exactly the kind of answers that you are expecting. So,
and of course, this requires some iteration, and you need to adjust your prompts and your system prompt, etc., to make sure that you get consistent results.
Right.
So, okay, so when we start thinking about this process, one of the things is, okay, but copying and pasting is not the ideal solution. So, and I have a lot of data. So where do I store it? How can I leverage my data? So what the industry is using mostly is vector database to store this. And we will understand this better. Filipe is going to explain all the black magic of vector databases. And guess again, a lot of math.
No, I was going to say, I heard vector, and I didn't dive on the inside, but it's okay. It's math again, right?
Yeah, it's math again. So we are using the vector databases to create an index of our data. In some vector databases, you can also store your data there, okay, and retrieve immediately your data, or you can only use it to create an index. So look at this as, okay, if you have an encyclopedia, what's the best way of searching an encyclopedia?
Start from the first page, no?
You go to the index. You're not scanning the full encyclopedia, right?
Great.
So you need to create an index, so it's easier to go into a couple of pages and then go to the part of the encyclopedia, page 1000 something.
Right. So I'm reducing my context, right? When I use the index, I'm reducing my context where I'm going to search for.
Much more efficient to look into 3 or 4 pages than scanning the whole book, right? So this is the same concept. So you are storing an index in your vector database, and then that index will tell you, okay, go to page something. So go to get this kind of information, or if you have it stored there also, you can already retrieve the information. So this is the retrieval part where it's coming from. And then I can pick that context and provide to the LLM and get back the answer as I explained previously. Okay. So let's hear about vector databases from Filipe.
Thank you, Sergio.
Math. Sorry, go ahead, Filipe.
This will not have math, but if you dig deeper, I will assure you, you'll see very simple math. For you who have some base on engineering, you will understand that quite easily.
Got it.
Okay, so before going to the vector database, let's understand what is a vector. So a vector is nothing more than a numerical array. A numerical array has several numbers, several positions in which we will call dimensions. And basically, in data science, a vector, anything is representing, or everything can be represented with an array, with a multi-dimensional array, where each dimension will be a specific characteristic of that element. This is widely used in the data science because, once again, the methods we use to compare, to process, to do operations over this data can be achieved with simple math operations.
Got it. Okay.
Not only simple, but also. Okay. So everything is a vector. And for this to have more visual to help you understand, I've taken this example actually from Spotify, where I have 4 different songs in which each song is composed in a vector of 3 dimensions. This is just for the exercise. The usual dimensions of a vector can go from 1,000 to several thousands. It will depend on the module. We'll cover modules later. Okay, so looking at this example, we see the song from the Beatles, Here Comes the Sun. And Here Comes the Sun is classified with 0.98, so the maximum is 1. So 98% in rock, almost no classical, almost no electronic dance music. Okay, if we look for Furious from Beethoven, we have lots of classical, almost no rock, and no electronic dance music. The song from Avicii, on the other hand, it's all about electronic dance music and no rock and classical. And finally, the Queen song, Bohemian Rhapsody, has lots of rock, lots of classical, and not so much electronic dance music. So this very simple set of vectors can be just like the ways we could build a recommendation engine here. Just get me the vectors that are most alike. And how would we do that? Just find the ones that have the closest values across each dimension.
Okay, well, simplifying like that
Yeah.
makes sense. Makes sense.
Okay. But of course, imagine this in a vector with 2000 dimensions.
Mm-hmm, mm-hmm.
You need lots of computers
I
to
understand.
do that. Okay. Now I'm talking about embedding modules and why. Because how can you transform anything into a vector? And the answer is through embedding modules. So what is an embedding module? Embedding module is just a module or an engine or a process, if you want, that allows you to convert anything like text, image, video to a vector. And there are three key features of an embedding module you should be aware of. The first one is that it reduces dimensionality. This basically means it is able to summarize a huge amount of data in just a simple vector with fewer dimensions. Imagine your friend that knows so much about a complex topic that he's able to explain you that complex topic into sentences.
Okay.
He's a good embedding module.
Okay. Well, I got that one.
Okay. Also, it captures semantic similarity, placing similar items near each other. Once again, if we have standard vectors, by using simple math operations, we can detect easily which vectors are more
close. Okay.
Remember the musics, which musics are more look
like, yeah.
And because of this, it's adaptable for natural language process applications, computer vision, search engines, recommendation engines, everything that looks like magic. It doesn't look like magic nowadays, but it still surprises me sometimes.
Yeah.
Okay. How can you suggest me that? How do you know I would like to see that? Okay.
Hey, welcome back. Sorry, we had some technical issues here. Sorry for what you've lost. Let's go back here just a little bit, so we can catch everything. So, Filipe, we were talking about the embedding model, right?
Embedding model. So, hi again, everyone. We're not quite sure where this gone wrong. So, I believe it was somewhere around this. What about choosing embedding model? For you to be aware, there are tons of embedding modules, just like there are tons of LLMs, and you should be able to choose the most accurate one for your own needs. So I would like to leave you with 3 key points to help you choose the best embedding module. The first one would be choose the best one model based for your task. If you're doing image recognition, if you're doing some comparison, just choose a model specifically built for that. The second one would be efficiency. Choose balance accuracy and computational resources by selecting the model with the right dimensionality. Don't choose a model that will return you 5,000 dimensions if you only need 1,000, or if your use case is too simple. And finally, do not use modules for a different purpose than they were designed to. Basically, fit the model to your data. Summarizing vectors and embedding modules. So the embedding model will allow, once again, to convert almost any piece of information to a standard vector. Either can be a text, can be an image, or can be audio. This will convert your information to a standard vector with the same number of dimensions within the same embedding module, which will basically allow you to having the vectors all standardized to do all the operations, the analysis, the processing you may need. So answering question from Sergio, where to store vectors. We could think about traditional databases, but we know that traditional databases are designed to, or optimized to store transactional data under rows and columns. We interact with them with SQL queries, so we must know exactly what we're looking for. And the vector databases on the other side are designed to store vectors. They are very optimized for all the AI and machine learning algorithms and provide us with similarity search, which basically means from one vector, I can get all the vectors that are near or not so near one vector, depending on my needs. And these vector databases are built from scratch to be flexible, scalable, and performance. So for us, from the user perspective or the developer, we just need to guarantee that we just throw the info in and the database will manage everything with black magic or something.
Yeah, black box at least.
In the cloud. Okay. In the cloud way. Okay. And then how to feed the vector database, Sergio?
So going back to what were discussing previously, so our RAG example. So we have the vector database. Now we know how the vector database works. So there's another question. So how do I keep my vector database up to date with my information? Okay, and so that's what we explain here very briefly. So we need to have our data sources with our text or our records, whatever, and we need to send that information to our embedding model, as Filipe explained, so to calculate the vectors for our index, and then we will send that to the vector database that will store the index with our embeddings. As Filipe was mentioned, depending on the model, it will generate different approaches for the vectors, but it's important to use the same model for storing, but also then for querying using the same model, or then the math will not do very well.
It'll never work.
Yeah, exactly. So what are the things that we need to have into attention in this process? So we need to make sure that we have the information curated, meaning that relevant information only, making sure that the information that we have, it's correct. We're not feeding with more data that could generate hallucination. We should remove unnecessary data, for example, for formatting that is not adding value to the content that we might be providing. And we might need to also chunk information. So this is also because LLMs typically have a context window. They have been growing, but typically they have a context window. And this means that the maximum amount of text that you can pass to the LLM, this includes your prompt, the system prompt, the context that you're passing to the LLM, will have a limit. Okay. So if we already index our information into small chunks, so maybe one page of the encyclopedia at the time, it's going to be easier because we'll retrieve only one page and we'll send that to the LLM. So fine-tuning this chunking is also important. It's something also to have into consideration when ingesting our data to the vector database. And then we need also to think of the life cycle of our data, meaning that probably we want to keep the information up to date, and we will need to have a process in place to keep updating this vector database so that we always are having the best results. So, okay.
Sure. Makes sense.
Just a small note. So some vector databases already have their own embedding models, and so you can maybe skip some steps here if you use those kinds of functionalities.
Okay.
So let's now put this in the context of the retrieval and understand how can we get our information, or how this is going to work in a RAG approach. Okay, so going under the hood. So our user starts with the prompt. It may be the previous prompt that we had when Portugal was founded, and then this prompt needs to be sent to the embedding model. So what we are going to do is convert our text into the vectors, so into the numbers in the vectors. And with this, we can use this vector of the prompt to query the vector database. Okay, and this will execute a similarity search, for instance, to our vector database, and this will give us some results that will be ordered by the closest one. So the ones with the smallest score in this case will be the ones that have closer similarity to what we are asking to the vector database. And as you can see here, what we opted to is, okay, our vectors are linked to an ID. We have the number 2 and the number 4, these two IDs. And we get the closest result in this case, and we use the closest result, and there's ID2 to get information from our knowledge base in this case. Since we didn't store information in the vector database, we only indexed it to the vector database. Now we're going to get the real deal, the text that we want to send to the LLM. And now our knowledge base will get us information. Could be a database, could be an API, could be many things. And we can combine our chunk of context with the prompt and send it to LLM as we've seen before. and get the response. So what we are automating here is that process of getting the context more easily with similarity. So context that is meaningful to what we are asking, and using that to send to the LLM to get a good response. Okay, got it. How can we take this a step further? So you probably already seen this concept of engines over there in the industry. ChatGPT Plus, for instance, has this concept where you start seeing agents that are more specialized in doing specific things or in specific knowledge or with doing specific tasks. Okay, so let's explain a bit more how can then you can pick up on this technique to expand into an agent. Okay, so let's start by defining what is an agent. Okay, so at the center, we'll have still the LLM. We'll always need to have one LLM. We'll have one interface, could be a chat window. It's the most common one that everyone knows, but creativity here, I think it's where...
it could be a voice interface, like
be a voice interface, could be many other things, and I think the creativity here can really make the difference in terms of how you expose your AI to your customers, to your users. And then the prompt recipe for the system prompt. So this is what is going to help define who the agent is, what is the agent. So it will have instructions for how it should act, what it should answer to, and what's the persona it's going to enact, for instance. We can give lots of instructions here. And then there's the knowledge part. So the knowledge base, we already seen how to leverage the knowledge base. And then some systems also already have built-in functions to help you keep up memory of a chain of questions and answers, for instance, and also use that as context. And with this, you can even get better results in this context, okay? And so this is what the agent will know to answer. And then the agent can also have tools. So you've probably already seen some agents that can search the web or can use calculators because they're not very good at math. They are different from Filipe, that is good at math. Or they can execute APIs to do stuff. So this is the next step, and I think it's the increment that completes everything, and then we will see more and more progress in the industries that LLMs will start doing more and more actions and execute more and more tasks with resort of tools. Okay, so that's what the agent can do.
Yeah, that's the potential of having an LLM, well, an agent based on an LLM that actually is going to execute something in my systems, right?
Yeah, exactly.
In my APIs or wherever.
So if you want to automate tasks, you will see these kind of agents more and more, and not only to
that's the full potential, probably, right?
Well, I think it's the next step. Although we're already seeing it, it's going to be, I think, the next step in terms of what are the use cases that will we'll see more happening in the next months and years. So at this moment, what are the two main types of agents that we're already seeing in the industry? Probably there's more, of course, but the ones that I could identify and classify was these two. So the first one is conversational agents. So they are typically chatbots. They can be used for customer service, for educational purposes, as assistants, for entertainment purposes, as voice assistants, as you said before. There's lots of applications for that, and they typically mimic an interaction between persons. So it's like conversation or a discussion or something like that. So the main interaction is like that. They usually can be used also to gather information in an incremental way. And we typically can see that in support agents and stuff like that.
Instead of a wizard with a huge form, you can have like a bot asking you questions.
Asking you questions and collecting information towards something. And they can evolve with more knowledge and more memory of the interactions that they are getting from other users as well. And then there's the other set. So that's, for me, the set I was mentioning before, that are the more task-oriented agents, where they are more working towards a goal, towards an objective, or they can be used to implement workflows or very simple workflows. And typically, they can be used to break down tasks into more manageable subtasks, and then execute tools like APIs or whatever to accomplish those workflows.
Okay.
Yeah. And they even can formulate plans to achieve the goal that you ask them and be more autonomous. And this is where I think we'll see more evolution. And on top of that, you can combine multiple agents that are working together as a team and working on the outputs of each other to improve something. So imagine that you have a software team and you have an agent that is the architect, you have an agent that is the developer, the other is the QA.
Okay, that's interesting.
Yeah, and they can work together to accomplish a task. And one can say, okay, you need to fix your code because we have an issue here. The architect can do code review on top of what the developer agent done, and they can be interacting in an automated way and producing this with very rapid interactions between them. So there are already some frameworks to accomplish those kinds of things. I think they still need, of course, to evolve, but I think we'll see more and more of
It's a matter of time, right?
Yeah, as usual. So, and that's it. I think now it's time for our special guest.
Yes. I was thinking kind of ironic, right? I'm doing this kind of question, then I'm the one doing the demo, right?
Yeah.
So what I'm going to show is it's a demo using the OutSystems platform and some other third-party components here to do a demo on RAG. So what we are going to do here is going to show you a solution where we will be storing information from our knowledge database. So we have our information, our own. So to complete what the LLM already knows, we are going to use a knowledge base that has like an identifier, content, and also an external link where that content was collected. Then we're going to take this, we're going to pass through an embedding model, and then we're going to store this in the vector database. To do this, now the tools, so the OutSystems, the knowledge base will be in an OutSystems application. The embedding model, we will use this model here, the ADA 002 from OpenAI. And for the vector database, we are going to use Pinecone. Okay, so except for the OutSystems part, all the rest could be different, right? It's just a matter of selecting the tools that do these kind of tasks of embedding and storing on the database. Now, this is to store information. To collect the information and to answer a person that writes a prompt in our application. So I'm going to use exactly the same scheme that was showing. So we have the prompt, the user gets a prompt. This prompt is going to be sent to the embedding model. So the embedding model will then query using the vector database. It will return the results, right? And then we're going to use one of them, get from our knowledge base the text, because we only got the ID. And then from here, we're going to go to the LLM, joining the context and the prompt, and we'll get the response. So again, the embedding will be done with OpenAI. The vector database is going to be Pinecone. The knowledge base is the OutSystems application. Okay. And the LLM, what we are going to use here, it's the GPT 3.5 Turbo. There are many more models or more recent, but we'll use this one that is up and running. It's actually a cheap one. So not that this is a cheap demo, but we're going to use it anyway. Actually, I have to see if this is my credit card then. So this is what we're going to do. Okay, so the demo time. What we're going to build? It's a really small and simple agent. If you want to, it's a UI that you write a question, and it will look at the knowledge base to see what would be the answer and give us an answer by the LLM. Okay, so let's get there. So I have here my application. Okay, I'm going to write the question. I think was, when was Portugal, right, founded? And we are going to ask that question. And in this case, we don't have any information. Okay, so let's try to understand what is going on here. So the knowledge base, like I said, we have some information here. Okay, so by the Kingdom of Spain, of the United Kingdom, Netherlands, but we don't have anything from Portugal. So let's add this information here. So we're going to add to our knowledge base that information that we have from our diplomatic portal about Portugal. let's get all of this information here. And what we're going to do is we're going to add that information. So the title is going to be, well, information portal, looks like a good title. And let's just copy paste this here. And let's just save it. Now in our knowledge base, we already have this, but you can check that this information hasn't been stored yet on our vector database. So I'm going to click here the store on the vector database, and this will run a timer. And let me show you the code. So what we're going to do is we're going to our knowledge base information, the one that isn't yet stored in the database. We are going to create the embedding in OpenAI, get the vector and use that vector and store it in Pinecone. Okay, we're going to get the embedding. We are also giving as an input parameter the ID that is the reference on OutSystems side of that content. And when it's success, we just store it as a success. And if we refresh it, okay, the information is now stored in our vector data. Okay, so going back to here, let's do exactly the same question. So when was Portugal founded? And now we'll ask the question, and you'll see that the answer was that Portugal was founded in 1143. It has the link. It's correct. Okay, it worked. So how was this built? So on the ask question, we are creating the embedding for the question. So taking text and retrieving a vector. We are using the get embedding matches from Pinecone. So we're sending a vector and receiving back the information of the matches that were found in the vector database. If we have a match, we'll get the content, okay, on the knowledge base. And after that, we are going to ask for the LLM to give us a completion. We're going to send the question that was written and the information that we got from the vector database, going to the knowledge base and getting the text as the context. And after that, we're going to show the result. Okay. So one last thing that I wanted to show is we actually have this here. So we have the embedding. So this is the embedding of the question. So it's the vector that was the result of embedding this question. And I'm going here to Pinecone, and you can see that I have my index here. And I can actually query it here. And if you see, I can have the top K, but let's say just the first one, and you can see that the first one that we got, the score here is 0.86, the ID is 8, and if I check here, it's going to be my ID 8. It will be the information here about Portugal. Okay, so this shows how the loop. So it's close between storing the information. It's a very simple example. It's actually based on what you showed and explained. And that's what I wanted to show in terms of the demo. Now, time for Q&A. I don't know if we have any kind of questions that are still unanswered in the chat. I don't think so. Maybe we were super clear. Well, if not,
maybe I can do a question, Bruno.
Oh yes,
Yeah, of course. So I think people will ask if they need to do all of this to build their agents with OutSystems. If this is the best way or the best approach.
Is that your question? Do I need to do all of this?
It's a bit suspicious.
Yeah, that's actually a very good question, Sergio. Thank you very much. Well, by the way, we are going to talk about on the next session for AI Agent Builder. So all of these that you've been seeing. So we've tried to show how RAG works. The fact is that you can use the OutSystems AI Agent Builder that hides all of this complexity from the developers and allows you to create agents based on the information that you have stored in your known knowledge base without having to do all. Well, it wasn't much code, but it was some code. So this is a good opportunity to announce that on September 10, we will have this session about AI Agent Builder. You'll get stuck with me. I'll be here also, but we'll have the presence here of Nuno Carneiro from our he's a product manager from our AI team to talk about this and to see what is the potential of the AI agent. Now, To everyone that has been with us, thank you very much for attending. Thank you very much, Sergio and Filipe, also for you being here. Just want to let you know that everyone that is interested, these sessions will be in a playlist in YouTube that you can check later. Also, there are more episodes. It's episode 7, so we have already more 6 episodes that you can check if you're interested in this topic. I hope you enjoyed at least as much as we did. Sorry for the technical issues, but it's the risks of doing this live. So again, Sergio, Filipe, thank you very much. To every one of you, have a great day. Thank you very much. See you next time.
Bye-bye.
Bye.